Welcome to this web lecture about user interface and interaction design. Design is, first of all, a process. It's a goal-directed, creative, problem-solving activity informed by intended use, target domains, materials, cost, and feasibility. There are many keywords here, right? It is a creative problem-solving activity. So creative means that it requires you to be creative. It can be a problem for some computer scientists who are good at problem solving, right, when there are standard approaches. We have to take into account the intended use. Who is going to use it? What is the application domain? And unfortunately, we have to consider whether it is feasible to produce what we want with reasonable cost and using materials. Materials can also be software environments that we have available. Design is also a decision-making activity. We have to balance trade-offs. We cannot always produce the best result that we have in mind because it is too expensive. We always work with a budget. The number of credit points for this course is your budget. Design is also a representation. It is documentation and plans that you have to deliver in the end. So there is a plan for how the development is going to work. There is a discussion of alternatives that you consider and of which you only are going to develop a few. Right? And there is a successive elaborations. The design goes from the brainstorming, the alternatives, to prototype development, and in the end, to product development. There are 4 basic activities to consider. First of all, we need to establish what are the requirements. What do the users need in order to perform their task? Once we know that, we can offer them some alternative ideas, some initial designs. So give them to the users, get some feedback, right, and decide which of these possible alternatives have any chance of being successful. Then, for the chosen designs, we're going to build early prototypes. We build interactive versions of these designs so that the users can start playing with these interactive versions. So an important 4th step is evaluation. And that's not a final step in a sequence. Right? These are the 4 activities, but we will iterate them a number of times. The evaluation may tell us that we missed one of the requirements, or maybe one of the designs was not so good, or maybe all the designs were not so good and we need to come up with yet another new idea. So it is an iterative process. What we definitely do not want to do is what software engineers do best. And it's called system-centered design. In system-centered design, the design choices are motivated by technical reasons. You make choices because technically these are, in most cases, the easiest technical solution. They are the best, maybe even the best technical solution, but they may result in an interface, an interaction the user doesn't like. What does the engineer do? The engineer will try to explain to the users why the system works the way it works. And the engineers do not hear the users who say, but I want it to work differently. Now, we are going to do that differently. So we have to forget about best technical solutions or easiest technical solutions. We have to forget about keeping a close mapping, often one-to-one, between what is available in the interface and what is available in underlying functionality. We do not want to repeat the mistake of, say, car manufacturers who give us cars with interface elements we really don't need. We don't need to know about a clutch and about transmissions when all we want is acceleration, maintaining a speed, and deceleration, braking, right, to stop again. So that's what we're going to do. We're going to forget about the system-centered design, and we're going to do user-centered design. So there is an early focus on the users and their tasks. We need to, first of all, know who our users are. Are we developing something for children, for adults? Is it a work application? Is it a play application? What are the needs? What are the cognitive abilities? And if we create something for university people or for people with not even a high school degree, their cognitive abilities and especially their existing knowledge may differ significantly. People may also have different attitudes. It doesn't really help to try to make filing taxes great fun. There is no interface that will make people think very differently about filing taxes. We will use empirical measurements. We're going to observe and analyze users' reactions. How users think about the interface, that's the most important thing. And we will start doing that right away from the beginning, using scenarios, later manuals, then simulations and prototypes. We're not building a product and then giving it to the world, hoping that everyone will love it. We will start doing evaluations very early on. So it's an iterative design process. Each time you find problems, early in the design, like in scenarios, we fix them, develop again, carry out more tests all the time. There are two variations that we consider. One is task-centered design. We are not only concerned with the needs of the user, but we focus on what is needed for a real-world task that needs to be performed. The cognitive walkthrough method that we saw in the evaluation part of this course is very important here. We design an application. We're not building anything yet, but we know how it's going to work. And we can perform a cognitive walkthrough to check whether each step needed to perform a task is believable. Good user-centered design leads to expectation management. When the users are involved in this process, they have realistic expectations. They see us throughout the development process. There are no surprises at any point because they know what we're working on. And so there are also no disappointments. They know what they're going to get. They also know what they're not going to get. And by working with the users, we offer them timely training. We communicate about how things are going to work. We are not doing advertisements, promising them things that in the end are not going to be a reality. Users that work with us get a sense of ownership. They feel that they contributed to the development, and so they become active stakeholders. They are more likely to forgive that there is a problem and to accept that there is still a problem, maybe a problem still to be solved throughout the development. This ownership can make a big difference between acceptance and success of a product or failure. We need early adopters who spread a positive word, a positive vibe about a product so that other people who are more neutral about it become enthusiastic and want to buy the product. So another variation that we apply, and that I already alluded at, is that we do participatory design. The users are part of the team. They're first-class citizens. They're members of the design team and actively collaborate in the design and development. And we need users because they know the task best. They are subject matter experts. They know what the interface in the end needs to support. And so the iterative process is also an interaction between the designers and the users, where the designers learn more and more about the task from the users, and the users learn more and more about what is possible in user interfaces. Their ideas initially, right, may not yet be optimal and may improve by getting to know the technology that we use. Participatory design is great, but it also has a few problems. It is great because the users are good at giving us feedback to suggestions that we make as designers. They contribute knowledge from the task domain, so we know better what needs to be in the application that we develop. And the participating users will become advocates. They will convince other people to buy the product. But there are problems. First of all, it is hard to get a good pool of end users. Where do we get these people who are willing to work with us on a product that does not yet exist? They're not just early adopters, they come before the early adoption. They are part of the development. Another problem is that users are not expert designers. And so their ideas for what they want in the design may be underdeveloped, but we need to think with them. And generally, the users are not always right. Their opinion can sometimes be wrong, for instance, because they don't know what is possible with the technology. Now, we will be users for the prototypes that you develop in the final project, and rest assured, as users evaluating your project, we are always right. Thank you for participating.